All right. So let's take a look here at what we've got. All right. So we already kind of have an idea about what makes a polynomial a polynomial. Okay. So let's see. Yeah, we'll just jump into this. I don't think we need to do this. Okay. So let's just say we want to simplify. Okay. So we've got two polynomials we want to add here. Four x squared minus x cubed plus 2 plus 5x to the fourth. Okay, that's one polynomial. And we're going to add to that negative x plus 6x squared plus 3x to the fourth. Okay. Okay. All right. How do we do something like this? What do we do? 3x to the fourth. Okay, and how do we know that they go together? Okay, yeah, they're like terms, you could say, right? They both have an x, and they both have an x to the fourth power. And so these, okay, are like terms, all right? You can really think of it like way back, you know, kind of to the idea of if you have 3x to the fourths, right? When you have 3 times x to the fourth, that means you have 3x to the fourths. And if you have 5x to the fourths, how many, and you're going to add them, right? How many total x to the fourths is that? It's 8x to the fourths, right? So in other words, the powers don't change when you add like terms here, right? They're just like terms, and you get 8x to the fourth. Now, Julian, is there any particular reason why you started with these two? Okay. So yeah, Julian is being a little more efficient for us, okay? If you guys, you know, don't see that there. He went ahead and found the highest degree common terms there to find and put out front, okay? Because he kind of already has an idea that, you know, a lot of times we want to have our answer in standard form, which means highest degree, then next highest degree, then next highest degree, so on and so forth, right? So that's a smart strategy to use there. You don't have to do it. You can wait and rearrange things later if you want to, but it's not a bad idea to do it at first because it kind of kills two birds with one stone. Okay? So then what's our next highest degree term in here? After the x to the fourth term, what comes next after that? Okay, x to the third. Do we have any other like terms with this? Nope. So we'll just bring it down. Minus x to the third. Okay, so we took care of that one. All right. Let's see here. Do we have any other things? What's our next? So we have squared would be next, right? Do we have anything like with the squared? We have the 6x squared, right? So again, 4x squareds plus 6x squareds, 10x squareds. Later, when we multiply, we will be changing the powers and stuff like that. But for right now, since we're just adding, we just combine like terms, and that's it. All right. What's going to be next after the 10x squared? What do we want to put in next in order? Negative x, and that's all there is, right? So we'll just put the minus x there, and then last but not least, the 2. Okay, and there it is. Both all the like terms are combined, and it's in standard form. Okay, I'll be a little bit more forgiving with you guys when it comes to, you know, like the directions here don't say to put it in standard form. It's kind of understood that we do need to do that, so you should be able to if asked. But if you don't end up putting it in standard form, that's okay. But you should be able to do it, for sure. You should be able to do it. Okay? So that's all there is to it. That's adding. All right? That's adding. Let's go ahead and look at subtraction then, and then maybe I'll give you guys two to practice here. So, all right, so let's do this. How about 12x to the third plus 5x minus 8x squared plus 19 minus 6x squared minus 9x plus 3 minus 18x to the third. Now, silence this. The subtraction sign here is in front of a group of parentheses. When we have something in front of parentheses, what do we normally do with that thing? We distribute it, or we do that leave change, change, or same change, change, however you want to call it there. Right. Everything after this minus sign that's in the parentheses, everything after the minus sign in the parentheses, it gets a minus sign distributed to it. So in other words, we're going to go ahead and, I'll write it this way. We'll distribute the minus to this term, to this term, to this term, and to this term, okay? There's no minus sign in front of the first polynomial, so you can drop the parentheses. You don't need them there anymore. Okay. But then this will become minus 6x squared, minus a negative, so plus 9x, minus a positive, so minus 3, and then minus a negative, so plus 18x to the third. Okay, so essentially we just make all these signs opposites. Okay, and now it's just like the first one, right? Just like the first one, we're going to combine like terms. So, Gio, what's the highest power you see here for this one?
Power to 3.
Okay, power 3. So do we have, so I see 12x to the third. Is there anything like with that?
18x.
18, yeah. So we're just going to add those together. We get 30. X to the third. All right. What else there, Gio? What else do you see there?
8x.
Okay, the minus 8x squared. And that's going to combine with the what?
The negative 6x.
So minus 8, negative 8 minus 6 is going to be minus 14. Again, notice my powers are not changing because we're just combining like terms here. Okay? If you have 2 apples and you add 3 apples, you don't have 5 apples squared. You have 5 apples, right? So if you have negative 8x squared, you take away 6x squareds, you now have negative 14x squareds. Okay. Okay. What's next, Gio?
The 5x and the 9x.
And the 9x, and it's 5 plus 9, so that'll be 14. Okay, that's gone, that's gone. All right, anything else, Gio?
The 19.
19? And that makes? 16. And there is our answer, okay, in standard form. All right, so here, real quick, I'll have you guys try too, just to make sure you're feeling all right with it. Let's have you do negative 8x plus 3x to the 11th plus x to the 6th plus 4x to the 4th minus x plus 17. Okay, so try that one. And excuse me. 23x to the 7th minus 9x to the 4th plus 1 minus, I'm going to be off the screen maybe. Maybe I can put it on there. Minus negative 9x to the 4th plus 6x squared minus 31. Okay, did it all fit? Almost. Okay, there we go. All right. Try those two real quick. Try those two. See what you can come up with there. It's negative 8x plus 3x to the 11th plus x to the 6th.
The 4x to the 4th power, or then
4x to the 4. 4x to the 4. Okay. Sorry. It's, negative 8x plus 3x to the 11th plus x to the 6th plus 4x to the 4th minus x plus 17. 23x to the 7th minus 9x to the 4th plus 1 minus negative 9x to the 4th, 6x squared minus 31. Okay. 23x to the 7th minus 9x to the 4th plus 1 minus negative 9x to the 4th, 6x squared minus 31. Okay. 23x to the 7th minus 9x to the 4th plus 1 minus negative 9x to the 4th, 6x squared minus 31. Okay. Well, that's the idea. This one. Okay, this one. Multiplication next, but again, it's review, so you might be okay. Yes. Which one? These two right here? Okay. May I jump in right here? Yes, 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 yes. Yes, yes, yes. Awesome. Well done, sir. We're going to multiply here in a second. All right. How to get those try? There we go. All right. Why you guys okay? Mind if I look? I'm ready to paper and ask you a question here. Recheck that. Recheck that. Yeah. Yes, you can get those to me. I will take them. Or if you just want to show them that they have number on the spot, you don't have to tear it out. I'll just do that. Sorry? You can leave it. Yes. That's fine. I'll just figure it out. Y'all do it. Yes. Sorry. Oh, where did I put my notes? All right, let's go to Brandon. Brandon, what'd you get for your answer for this one right here?
3x to 11.
Oh, yeah, sorry. Brandon, oh, go ahead. Sorry, yes. Okay, you said 3x to the 11th
3x to 11
plus
plus x to the 6th
x to the 6th
plus 4x to the 4th
plus 4x to the 4th
minus 9x
minus 9x
plus 17.
plus 17. Yeah, this one was kind of lame. There was only like one pair of like terms there to combine, so that is your final answer. And in standard form, very good. Okay, this one wasn't very exciting. All right, let's go to Brandon S. Brandon S, please, for the second one there. What'd you get for your final answer there, Brandon S? Did you get your final answer there, Brandon? You get to finish that one? Okay, that's fine. Do you want to walk through it together, or do you want me to call on someone else? Call on someone else, or together? Together. All right, cool. So we have a minus sign in front of parentheses, right? Okay, that minus will distribute to all three of these, right? To this one, to this one, to this one, right? These, there's nothing in front, okay, to distribute, so we'll just leave it. 23x to the 7th minus 9x to the 4th plus 1. Ugh. And then minus a negative becomes what? Yeah, plus 9x to the 4th there, minus a 6x squared. And again, minus a minus becomes plus 31. Okay, Brandon, what's our like terms here? What are our like terms? Yeah, we have a negative 9x4 and a positive 9x4, so they what? Cancel. All right, so well, let's bring down that 23x to the 7th there. That's good. So yeah, the 9x's cancel. Okay, what would be then next here? What will be the next kind of highest power to work with after the 4s? I put on the 7s. So. And is there anything like with that? Nope. So we just minus 6x squared. Okay, that's gone. And then any other, the next after that would be an x, but we don't have x's, so it's just our numbers. So then what do we get at the end there? We have 1 and 31. Does that make, 32. Good job, Brandon. That's right. Okay, well done. Okay. All right, let's continue on then. So that's adding, subtracting, something you guys have been doing for a while now, I'm sure. Let's now talk about multiplying polynomials, okay? Because that's can be a little more involved. Okay. Okay. Again, we'll just simplify here. Right. So we'll start out real basic, and then we'll kind of like, get to more advanced stuff. Okay. So here's a polynomial times a polynomial, but more specifically, it's a monomial times a monomial, right? One term times one term there. Okay. So when we multiply here, what multiplies together? The coefficients, good use of vocabulary there. So it's going to be 5 times 6, which will be 30. What else multiplies together? The x's. And what will we get when we multiply x to the 1 times x to the 3? X to the, not third, x to the 4th. Yeah. We add the exponents, okay? And why is that, right? Do you remember? So why do we have that happen? Well, let's think about it this way, right? What does 5x to the 1 mean? Well, it means really 5 times x, right? And what does 6x to the 3rd mean? Well, it means 6 times x times x times x, right? X to the 3rd means 3 x's, right? And when it's multiplication, you can rearrange your terms. So I could do 5 times 6 times x times x times x times x, right? So that x and then these 3, okay? And what is 5 times 6? Well, there's the 30, and there's 4 x's being multiplied together, and so there's your x to the 4th. Okay? So multiplication is a little bit different, right? Because another thing, right, are these like terms? No, but can we multiply like terms? Sorry, can we multiply non-like terms? Yes, we can, right? We can. We cannot add, we cannot subtract, but we can multiply non-like terms, okay? So you're allowed to do it, right? X plus y, you can't simplify that. X times y, well, it's just xy, but I mean, you can still put them together, right? It's like with fractions too. The same rule is true with fractions, right? Earlier, when we did like 1/4 times 1/4, we can multiply fourths. We can multiply 1/4 times 1/4. We can also multiply 1/2 times 1/4, right? You can multiply any fractions together you want. When we go to add fractions, right? If I want to take 1/2 and add 1/4, can we add fractions? The denominators are the same, right? Why is that important? Because they're not like terms. I have 1/2. I'm trying to add 1/4. They're not like terms. We can't add them. So we get like terms by changing this 1/2 to be the same as 2/4, and I'm going to add to it 1/4, and so now I will have 3/4, which is also why when you add fractions, the denominators don't change, right? It's only the numerators that you add. Because the denominators are like your term. You have 2/4, you're adding 1/4, so you have a total of 3/4. Okay? It's all related with combining like terms and stuff like that. Okay, it's all one big idea. All right, back to this. All right, let me do one more here for you. like these. Okay, 2x to the second y to the fourth z times 5, that's supposed to be a y squared z. And that's an equal sign, not a 2. So equals. Okay. So what gets multiplied together here? Okay, so let's do the numbers first. We have negative 2 and the 5. That makes negative 10. All right. And sorry, what else multiplies now? Okay, the y's will get multiplied. We have y to the fourth times y to the second. What's that going to become? Y to the sixth. And then what about the z times the z? What will that make? Z squared. And then what about this x hanging out? X squared here hanging out. Now you can put it there. Okay. Typically we do write them in alphabetical order, so I'm going to rearrange it here and just make it x squared, y to the sixth, z squared. Okay. And yeah, that's our final answer there. That's the best we can do. Oops, I'm off the screen. Sorry about that. Okay. That's the best we can do. Okay. X squared, y to the sixth, z squared. Those can't go together because they don't have the same base. They don't have the same base. Okay. I mean they're together by multiplication, but they don't. You can't like, you know, that's got a base of x. That's got a base of y. They can't go together. All right. That's your basic like monomial multiplication, right? But now let's up the ante a little bit here, make things a little more interesting or painful maybe. Okay. What can we do here to multiply these? Okay, distribute. What's another, maybe heard of FOIL before, right? You use FOIL or something like that. There's a couple strategies you can use here to multiply this, okay? The big picture, and this is what I want to really try and make as clear to you as I can, when you multiply two polynomials, okay, the big picture, all these methods that we use to help you kind of multiply these things out, okay, they're really just, you know, tricks in a sense. They're organizational tricks to just help you understand and see that every term here multiplies with every term here. So there's two terms here, the 2 and the 3x, and this 2 has to multiply with the 1 and the x, and this 3x has to multiply with the 1 and the x, and then you just combine like terms. That's what's really going on here. FOIL is just an organizational tool, right? The distributive method is what's happening here. I mean, again, that's what we're doing too. But it's all just really, this has to multiply with both of these, this has to multiply with both of these, and you add like terms. That's it, really. Okay, so I'll show you, I'll show you that here, the way Julian first kind of described right there. Okay, so the 2 times the 1 makes a 2. 2 times the x makes a 2x. 3x times 1, 3x. 3x times x, 3x squared. Okay. Right. And then we should combine like terms and put it in standard form here, right? So we'll put 3x squared first, and then plus what? What? 5x, very good. The 2x and 3x make 5x, very good. Geo, and then 2 plus 2. Okay, so there it is, all simplified. All right. There's another method that I think I've seen some of you guys use, one or two of you use, where you take the first thing that you're multiplying by, and you take the second thing that you're multiplying by, and you kind of like you make little like a little table kind of thing, and okay, it's like so to find what goes in here, you do 2 times 1, so 2, and then 1 times 3x is 3x, okay, and then x times 2 is 2x, and then x times 3x is 3x squared, and there are all your terms, okay, and you just add these together and get your final answer that way. So again, this is an organizational tool. It's not something that you have to use, but if you like it, yeah. If you like it though, okay, if that helps, please feel free to use it. Okay. All right, let's try another one. That was too easy though. Too easy. Let's try this one. Oops. So that's supposed to be 4x to the 1. I'm just going to wipe that out. Make the liquid paper it out. Ugh. Uh-oh. Okay. It still has like a little white splotch, but it looks a little bit better, I guess. Anyway. All right. So to multiply this out, you can again kind of use these little arches if you want to. But again, what's the big picture? Every term here has to multiply with every term here. So the x is going to multiply with the 1, the minus 4x, and the 2x squared. The 2 will multiply with the 1, the minus 4x, and the 2x squared. So it's going to look something like this. And like this. Okay. So x times 1, x times minus 4x, minus 4x squared, x times 2x squared, it'll be 2x to the third, and then 2 times 1, 2. 2 times minus 4x, 2 times minus 4x, minus 8x, and then 2 times 2x squared, 4x squared, okay? And then we look for our highest degree term, okay, it's the 3, and so we'll put that in front. There's no other cube terms there, so I can get rid of that. All right, I have a minus 4x squared then, and I have a plus 4x squared. So what happens to those? They what? We have a minus 4x squared. Yeah, and the plus 4x, they cancel out. Yep, they're gone, okay? Next highest degree is x to the 1, or x. So we have a positive 1x, and we have a minus 8x, that's minus 7x. And then last but not least, we have the plus 2. Okay? And there is our simplified polynomial in standard form. All right, ready to try one on your own? Oh, Gio, sorry. When AJ comes back, yes. Okay, you okay with waiting? Okay. Can I move that away there? Yes, we're good. Okay, I'll have you guys try one here. Excuse me. All right, let's have you try 3 plus 2x times 4 minus 7x plus 5x squared. Okay? Go ahead, give that one a try. Excuse me. 2x times negative 7x. So this will be x squared. And that's going to mess up what your like terms were there. So that's why your middle term, so this one was right, this one's right, the middle terms are a little off because, so that's all. What's that? 5x2. Yes, when Geo comes back. Yep, absolutely. Any other question? Yes, right here. We did the 2x times the minus 7x. It is negative 14. What's x times x? X squared. And then, same thing here, we did 2x times 5x squared. 2 times 5 is 10, but x times x squared should be x to the third. And so that'll mess up your like terms there too. So you have to recombine like terms. Anyone else want me to look at their problem before we go over here? All right, so here's what you should have gotten. Right there, 10x cubed plus x squared minus 13x plus 12. I chose to do the little table here, all right? One little thing I want to point out about the table, so I, again, just made like a little chart. I put the 4, and instead of a minus 7x, I made it plus negative 7x, right? So instead of minus 7, I made it plus negative. Same thing, though, right? But it's just helpful because you can see the minus sign more easily. And then the plus 5x squared. And then down the side here, I put the 3 plus 2x, okay? And then again, just drew lines through all the plus signs, okay, to create these 6 cells. And how do you fill in the cell? It's just the two numbers, right? 3 times 4 makes the 12. 3 times negative 7x makes the negative 21x. 3 times 5x squared, 15x squared. 2x times 4, 8x. 2 times negative 7, negative 14x squared. 2x times negative 7x is negative 14x squared. So a couple people, make some errors there. And then 2x times 5x squared is 10x to the third. And you can just combine like terms, right? You have all of your little terms right there. So 10x cubed, and then these two make the 1x squared, and then these two make the minus 13x, and that makes the 12. Okay? Questions on any of that? All right. These next ones, I do not want you to write down. It's just too much writing. But I do want us to just discuss them real quick here, okay? Well, actually, briefly, before I move on to that. Okay? I won't make you do much more than this. Okay? The worst I'll give you, so this is like pretty much the worst I'll give you. I may give you a trinomial times a trinomial. But again, it's just the idea that is every term here would multiply with every term here. Okay? But I don't think I assigned you a trinomial for the homework tonight. But really, at this point now, we can multiply any size polynomials together. It's just a matter of how much do we want to torture ourselves. All right, now, I just want to talk about a few of these problems right here. Okay. First of all, this is a wall of text right here. But let me just read through it real quick because it's actually much easier than you might expect. All right? The data from the U.S. Census Bureau for 2005 to 2009 shows the number of male students enrolled in high school in the United States. So the number of males in high school in the United States can be modeled by the function m of x equals negative 10.4x to the third plus 74.2x squared minus 33.4x plus 8,320.2, where x is the number of years after 2005, right? Because again, it's between the years 2005 and 2009. Okay? So big picture, what is this function m of x? This function m of x is just the number of male students in high school in the United States, okay, given the year, some number of years after 2005. Okay, so if it was the year 2005, you'd plug in 0. If it was the year 2006, you'd plug in 1, right, because x is the number of years after 2005. If it was the year 2007, what would we plug in for x? 2, so on and so forth, right? You get the idea? All right. and it's number of students in thousands. So the final, your answer would be in thousands. You have to multiply by 1,000 to get the actual answer. Okay. Of course, then the number of female students enrolled in high school in the United States can be modeled by the function f of x equals, and then this, okay, where x is the number of years after 2005. Okay. So if this function represents the number of male students, right, and this function represents the number of female students, okay, how can we figure out the total number of students enrolled in high school? What would we do with these two polynomials? If this represents the number of male students, right, and this represents the number of female students, what can we do to find the total number of students in high school, or to estimate the total number of students in high school? What could we do with those two polynomials? Add them. That's it. Just add them, okay? All that text, okay, was really just like, you need to add these two polynomials, okay? So yeah, the total would be m plus f. And of course, that would involve combining like terms, right? We have like a negative 13.8x cubed. We have a negative 10.4x cubed. You would add those together, right? Combine like terms. Okay? If we wanted to estimate the total number of students enrolled in the year 2009, what number, once we added them, then what number would we plug in for x? If we want to estimate, what's that? 4, because 4, right? 2009 is 4 years from our starting point, 2005 there, right? X is the number of years after 2005. So 2009 is 4 years later. You plug in 4 once you add these two things together, okay? That's it, okay? It's a long paragraph of words there, but it's the same idea. Let's see here. Okay, let's look at letter B here real quick. The data from the U.S. Census Bureau for 2000 to 2010 shows the total number of overseas travelers visiting New York and Florida can be modeled by the function t of x equals this, where x is the number of years, again, after 2000 this time. Okay? So this is the total number of overseas travelers that visit both New York and Florida together, okay, in thousands. The number of overseas travelers that visit New York can be modeled by this function. Okay? So this is the total number of people from the overseas that visit New York and Florida, and this is the total number of people that visit New York. What can we do to figure out the total number of people that visit Florida? What would we have to do here? Subtract, right? Do the total one, this polynomial, minus this polynomial, okay? And if we wanted to estimate then the number of people from overseas that came in 2008, what number would we plug in? Remember, 8, because in this case, x is the number of years after 2000. So you just plug in 8. Once you simplified, once you did this one minus this one, then you plug in 8. And of course, that number you get would be a number in thousands, okay? Because your n of x and t of x are both the total number of travelers in thousands, okay? All right. So that's just one little thing I want to show you there. And then I think I had a multiplication one here somewhere. Maybe not. Maybe so. Yes, there you go. Okay, yeah. So here's one right here. All right. Mr. Silva manages a manufacturing plant. From 1990 through 2005, the number of units produced in thousands can be modeled by n of x. So this is how many units of this thing they're making. Okay. X number of years since 1990. The average cost per unit in dollars can be modeled by this. Okay. So if this is the number of units they produce, and this is the cost per unit, what would be the polynomial that would represent the total manufacturing cost for a particular year? What would we have to do with those two things to find the total? If this is the number of units they made, and this is the cost per unit, what would we do with those two polynomials to find the total cost in a particular year? Multiply them. So you do this one, n of x, times this one, c of x, okay? Combine like terms and stuff like that. And then we would plug in. If we wanted to estimate for a particular year, it doesn't say for a particular year. Anyway, okay, you get the idea though. Good. Yeah, that's good enough for me. All right, so your assignment then. That'll be good. Okay, your assignment then. On page, 2 different pages in the book. Two different pages in the book. Page 203 to 204. I'd like to do numbers 2, 7, 8, 13, and 19. And then on page 212 to 213, I'd like to do numbers 2, 6, and 10. Number 10, you just need to set up, don't simplify. Okay, just set it up, but don't simplify. You'll see what I mean when you get there. Okay? So, that's out of the book. So again, you can pull the book out from the back there, or you can pull it up on your Google Classroom, your choice. Okay, your choice there. I can put the answers up here too if you want to come and check a little bit later. This will be the homework if you don't finish it in class, yes, but please do get started on here. Pull those books out. All right, I'll come around and help as necessary.